Hello. Today we will be solving this problem called subarray distinct values. So we are given an array of n integers and our task is to calculate the number of subarrays that have at most k distinct values. So the first input line has two integers n and k, and the next line has n integers x1 through xn. Here n and k can be as large as 2 times 10 to the fifth, and the values can be as large as a billion. This is the sample example. So in this case the answer is 10. So let's go to the drawing board and see why that is and try to come up with an answer. So this is our example. Let's go through all subarrays by fixing their starting point. So if a subarray starts here, like this is the first subarray that starts at that position, and it is valid because it only has one distinct value, so that's 1. This is also a valid subarray, so that's 2. However, if we move any further than that, we will have 3 distinct values, which is not valid, so we have to move our left boundary. So we move on to here. This is valid, so that's 3. This is also valid, so that's 4. But moving any further, we will not have a valid subarray, so we have to move our left boundary to here. So the singleton 3 is valid, so that makes it 5. Also, this is valid, so that's 6. And this is valid as well because now, even though we had 3 elements, only 2 of them are distinct, so that's 7. Next we move on to this left boundary, so we get 1 valid interval and 2 valid intervals, so we get 2 additional subarrays. And finally the singleton 1 gives us the 10th subarray. So in total we have 10 subarrays with at most 2 distinct values. So going through this example in this way gives us an idea about how to approach this problem. So we could go through all subarrays by having 2 nested loops. So for I equals 0, I less than n, I plus plus. For j equals I plus 1, j less than n, j plus plus. So I and j will fix our subarray. I will be the left boundary and j will be the right boundary. So now that we've fixed our subarray, what we can do is go through these elements in the subarray and see how many elements are distinct. And the way we could do that is using a set. So as a reminder, a set is a data structure that allows for insertions and deletions in log of n, and it only holds 1 copy of each value. So if we inserted 1 twice, it will only be inserted once. So if this is our set, and say we inserted the elements in this interval, so we'll insert 3, then we'll insert 1, and when we want to insert this one, it will not make any difference because there is already a 1 in our set. So basically all the elements in the set are distinct, and this will allow us to know how many elements are distinct in an interval by just checking the size of the set. So the size of our set, so size of set equals the number of distinct elements. So here we'll declare a set of ints, call it st for example, and then we will need another loop to go through the values from I to j. So for x equals I, x less than j, x plus plus, we would insert that element, so we would go like st dot insert a of x, and once we're done we will check if size or rather st.size. So if st.size is less than or equal to k, then we will increment our counter, so counter plus plus. Okay, but what is the complexity of this approach? So we have one for loop here, another for loop here, and a third for loop here, and in addition, for each element here we insert it into the set. So we said that insertions cost log n, and since we have 3 nested loops, the total complexity would be n cubed log n, which is way larger than what we can afford. So this approach will not work, but it gives us some insight into the appropriate approach. So here we saw in previous problems where we needed to go through all subarrays, there was a trick to reduce the complexity from n squared to n, and that is using 2 pointers if the conditions we want to fulfill matches certain criteria, like what we did here. Like at the beginning we said that we're gonna start by intervals that start at this position and keep moving the j pointer as long as the number of elements were smaller than the number of distinct elements was smaller than 2. So this would reduce the complexity of these 2 for loops from n squared to n, and that is because these 2 pointers will only move in one direction, whereas here j, after each incrementation of I, was reset to I plus 1. So j went all the way down to n, and each time it got reset. So to avoid that, we will use 2 pointers, but we need to know when to stop, and we will need to know how to count the number of distinct elements. So let me erase this. And see how 2 pointers could help us in this case. Okay, so now let's start with our example. So we'll say that I is here and j is here as well. So we will keep moving j as long as the condition that the number of distinct elements is smaller than or equal to 2. So here at the beginning there is no element in our set. Say we will use set for now, even though it will show to have limitations. So let's say we have a set. So we will insert 1 here and erase j, move j to here, then we will insert 2. The size of our set is still less than or equal to 2, so we'll move j further to this position, and then we'll insert 3, and at this position we'll see that the size of our set is larger than 2, so we have to stop, and we will just add to our counter j minus I. So if we add j, which is 2, minus I, which is 0, we will actually add 2, which matches the number of distinct subarrays that start at 1, which were, like we said, this one and this one. So that's good. But now, as we do with 2 pointers, now we have to move our I. So we will move our I here. No problem so far. But we need to delete this one from our set. Okay, no issue so far. So we'll delete 1 from our set, and we see that we have 2 elements here, so we have to increase j. We increase j to this position, so we insert 1, and once again we have 3 elements in our set, so we have to stop, and we'll add j minus I again, which is 3 minus 1, which is 2. So plus 2 again, and we'll move 2. We'll move I to here and erase 2 from our set. Fine so far. So if we erase 2 from our set, this means that we have to increment j again. So we'll increment j here, but since we already inserted one, this won't make any difference. So basically the set does not retain the number of occurrences of that element, and we will see where that is an issue. So for example, if we had this example instead, so if we had 5 2 again, but instead we had something like 1 2 1 3 1. Okay, so this is our set. We'll start I from this position and j from this position. We will insert 1 to start with, fine, and then we'll move j to this position too. Only 2 elements so far, so we'll keep increasing j, so we'll move j here, fine so far. We don't need to insert any other elements because 1 is already there. And now we'll move j here, so we insert 3. Here we have to stop because we have 3 elements, so we just stop here and increment our count by 3 minus 0, which is 3. And to clarify this point, I do j minus I because this is precisely the number of subarrays that start at this position. They can end here or here or here. And the number of gaps I have here is equal to j minus I. Okay? So now, as I said, so we have, as we did before, we have to move I now because this interval is not valid anymore, and with 2 pointers, when our interval is not valid, after moving the right boundary we have to move the left boundary. So I'll just move my left boundary here to this position, and as we did before, I'll just go ahead and erase 1 from our set. And this will tell me that I only have 2 distinct values, but that's not true because I have 3 distinct values in this interval. So I cannot just go ahead and erase this one. There may be other occurrences of 1 here. So that's why the set is not suitable for this operation. And instead I need some data structure that will store the elements I saw as well as the number of their occurrences. And that data structure would be a map. So I have to use a map instead. So let's see how a map would work with this example here. Sorry. So instead of a set, I will have a map here. And let's do this example once again. So this is I and this is j. And this should be a 2. So I'll start from here. J is at this position, so I have to increment the number of times I saw 1. So 1 was seen once. Clumsy me. So 1 was seen once. Okay, fine. I'll increment j to here. 2 was seen once again. And just to mention, map also has that size method that will tell me how many distinct values are in my map. So far only 2 distinct values, so no issue. I'll move j further. So I'll move j here. And so I have to increment the number of times I saw 1. So now I saw 1 twice. Then I will move j further here. So this tells me that I saw 3 1 time. And now the size of my map is greater than 2. So I have to stop and add j minus I to my count, which would give me 0 1 2 3 4 0 1 2 3. So 3 minus 0 is 3. And this represents the 3 subarrays that I can form starting from I. And now I have to increment I. But notice here the difference. I will not just go ahead and erase this element. What I will do is I will decrement the number of times I saw 1. So this becomes 1. And I will only erase this value if it is equal to 0. So I will not erase it in this case, But I will keep moving on, and in order to make things interesting, I'll just add more elements to my example here. Say we have 8 elements, and here I'll add 4, 5, and 6. Great. So I'm at this position now. I have 3 elements in my set still. So in my map, I mean. So I still have to move I. So I'll move I here. And notice what happens now. Now I will go ahead and decrement the number of times I saw 2. So this becomes 0. And since this is 0, I'll just erase this occurrence. And now the size of my map is only 2. So now I can keep increasing j. So I'll increase j further. So I'll move j to this position and increase the number of times I saw 1. And I still only have 2 elements, so I'll increase j further to this position. And now I have to note that I saw 4 ones, and now I have 3 elements in my map. So I have to stop and add this to my count. So the number of intervals I can form here is 1, 2, 3. So plus 3 here. And now I'll move I. So all what I have to do is erase this and decrement the number of occurrences of 1. And since it is not 0, I will not erase it. So I is at this position now. And this is not valid, so I have to move I. But before I do that, I have to add this to my count. So j minus I in this case is 2, so plus 2. And now I move I again, so I is at this position now, and the number of occurrences of 3 becomes 0, so I just erase it from my map. And now I only have 2 elements, so I can keep moving j further. So I'll move it here, and now I have 3 elements in my map again. So I'll just add the difference between j and I to my set, which is 2, and move I further. So I move I here, and since the number of occurrences of 1 will become 0, so I'll just erase this. And since my map has only 2 elements, I will move j further here, and I'll get a new element. So the size of our map is 3 now. So I have to add this to my map, to my count, so this becomes 2, and I'll move I further here. And since 4 has had only 1 occurrence, so this would become 0, and since that's 0, I'll just erase it. And now I can't move j any further, so I will just move it to the end of the array. So, and I will have to stop, and I will add the difference between these two values, which is 2 again. And I will move I further because that's the only thing I can do, and I will add 1 here. And that's my final answer. So using a map would solve this problem. So now let's check out the code. So this is my code. We start by reading the input n and k. Then we declare a vector of int that will store our values. I read my values. Then I'll declare a variable answer. And notice here that it has to be long because maybe all the elements are distinct. So if I had 5, 2 for example, and all the elements were distinct, then any subarray would be, or I mean if all elements were the same, I'm sorry. If all elements were the same, then any subarray would be valid. And how many subarrays do we have? If n was equal to 5, we would have 5 times 4 over 2, which is equal to 10. And in general, if we had n, we would have n times n minus 1 over 2 subarrays, and this is order n square. And since n can be as large as 2 times 10 to the 5th, this would be of order 10 to the 10th. That's why we need longs there. Okay, then we'll declare our 2 pointers I and j, and we'll declare our map that will store the number of occurrences of each value, and we'll just loop through all values. So inside our for loop we will keep moving j as long as the number of occurrences of our map is less than k, or the number of occurrences of that value is greater than 0. This means that if we were at this point, for example, and we had a lot of ones, we'll just keep on moving because adding these will not change the number of distinct elements. And after each iteration of j, we'll increment the number of occurrences of that value and move j forward. And when we stop, when j gets to the point where it's not valid anymore, when the size or when the number of occurrences becomes greater than k, then we just add j minus I to our answer. And we'll just now we'll have to move I, so we just decrement the number of occurrences of that value. And if the number of occurrences is equal to 0, then we'll just erase that value from our map. And at the end we just print our answer. So that's pretty much it. Let's go ahead and submit. So that worked. Thank you for watching. See you in the next video. Bye bye.